Welcome to our very first webinar on nRF Cloud powered by Memfault. We're very excited to share with you the amazing things we've been building and show you how we think you can use them to build better products. Specifically, we'll be talking about device management and observability, two core features of our cloud offering, which are available today for Nordic devices. My name is François Baldassari, and I am the VP of Software Services here at Nordic Semiconductors. Before we can get into the fun stuff, I need to run through a few housekeeping items. Today's presentation will run for about 60 minutes. I will talk for 45, and we'll have 15 minutes at the end for me to answer your questions. Speaking of questions, do not be shy. Please send us as many as you can. You can enter your questions in the top box in the right-hand sidebar. Rest assured that your questions are anonymous. So we will take them as they are and not consider who it is that is writing them. We will answer as many as we can. At the bottom of that sidebar, you will also see a chat. The chat is not anonymous, but we will have a few people there to animate it and answer your questions as you go. If at the end of this conversation there is more you want to talk about, you can always get answers and talk to us at DevZone. So don't hesitate to go there and create an account if you do not already have one. Last but not least, a recording of this webinar will be available alongside with the presentation materials at webinars.nordicsemi.com, so you can share it with all your friends, your colleagues, and refer back to it as needed. So let's get into it, and let's talk about building connected devices. All of you have been doing this for a while, and you know that building connected devices is only getting harder. And what is driving a lot of that complexity? It is software. Today, 60% of the cost of an embedded development project is driven by software. Cloud software, embedded software, mobile, desktop, all of the code, all the software that goes along with making your device work the way you want it to. And 29% of that cost specifically is embedded software, or as many of us call it, firmware. This software continues to grow and continues to get more sophisticated. Today, almost 30% of embedded projects have over 100,000 lines of code. And this increasing complexity is now the #1 driver of project delays. So software is bigger than ever, costlier than ever, and now driving our timeline. We talk to development teams every week here at Nordic Semiconductors, and we can see that they are struggling. Because although the complexity has increased a lot, the pace of development, the deadlines have not changed. The average project is in development for only 16 months. This is the same timeline that was expected 10 years ago before all of this software complexity came along. Not only that, but these products need to be designed well enough that they can work in the field on average for 8 years. This is extremely complicated when you consider the fact that interoperability is itself a moving target. How can you bulletproof your product so that it continues to operate as Wi-Fi standards change, the environment gets updated, the mobile phones release a new major OS? This challenge constantly bewilders teams, and we hear from them that they need a solution every day. By the way, we talk about this software development, but it's not just building the product that we have to do during this time. We have to also build all the infrastructure that is required to make that product work. Because in the day of interactive connected products, we of course need all the cloud services that come with it to make sure the products operate as expected, that they are secure, that they can be updated and maintained over that 8-year lifespan. By the end, we've had to answer questions like, does it work? How do I maintain it? Do my cloud systems scale? And so the work, in fact, continues and compounds over the entire lifespan of the device. This pressure is not letting out anytime soon. In fact, it continues to increase. Because cybersecurity is a growing concern in the IoT space, regulators are now creating rules and laws to add some additional security and therefore increase the compliance burden on connected device manufacturers. Foremost of these rules is the EU's Cyber Resilience Act. The Cyber Resilience Act establishes a set of best practices that companies must put in place to sell their devices in the EU, which includes vulnerability management, timely patching of software, and monitoring of the cybersecurity state of the device. So while we're already struggling with the complexity of getting a product to market, the increasing requirements of securing that product and the compliance requirements put in by regulators are only raising the bar and making it harder and harder to meet that competitive timeline. So what are teams doing today? Today, we surveyed developers and asked them, what is it that you do to wrestle with that complexity? What data do you collect? What systems have you built? And what we find is that the majority of companies, the majority of developers have actually started building in-house systems to collect data from their devices, get the answers they need to track down issues and optimize software development. But that itself has not been a silver bullet. Although better visibility allows them to react faster and build with more confidence, they'll find that it creates other problems. Now they have a new set of things they have to build. They have additional maintenance burden that is not well understood. How many developers do you need to maintain your internal infrastructure? They have new skills they have to build, a very complex set of technologies they have to wrestle with. And they have to face additional scalability risk, because building infrastructure for 100 devices when you're testing in your QA lab is very different from serving 1 million devices out there in the world. So it bears repeating. Developers are overwhelmed and under-equipped. Today, most of them in this new world of connectivity and software still only rely on customer complaints and bug reports to identify issues. That means that until a customer picks up the phone and says, my device isn't working, they have no idea that there is a problem. Half of them take weeks to find defects in the field. So by the time they're aware, their customers have been struggling with the problem for a really long time. And identifying, of course, is only half of the battle. Almost 50% of them take weeks to ship a fix once it's been identified. The end result is that engineering teams who should be focused on innovation and getting new products to market spend months every year fixing issues, debugging issues, root causing issues, or even just reproducing issues, spending time banging on a dev board to try to make it do the thing the customer is complaining about. This is because they don't have visibility. This low visibility puts projects at risk. They don't know what the actual performance is in the field. With low visibility, they have to spend a huge amount of time diagnosing, reproducing, and fixing bugs in the field. And as a result, they don't push updates nearly as often as they could or as they should, because it is so risky and slow to push an update to their fleets that they don't want to do it. They fear doing it. And of course, regulation makes all of that even more complicated. Because even if you were to build in-house infrastructure to collect that data, to do optimized software updates, to understand performance and collect bug information. You have to remember that a number of regulations also will impact the building of those systems. And so privacy regulation, things like the EU Data Act or GDPR, really complicates the effort to put this infrastructure together in a way that is compliant and privacy respecting for your users. So I hope you understand the shape of the problem. We're spending more and more money and more time developing software. We don't have enough visibility to manage that software. And when we do build infrastructure in-house, it creates additional cost, additional timeline risk, and compliance burden. This is why we've built nRF Cloud. nRF Cloud provides all the critical cloud infrastructure you need to manage your devices in the fleet and observe their performance, pre-integrated on all Nordic devices. It's available today, and it's super easy to use. And I'm going to show you over the next few slides all that it can do and how you can use it. Historically, nRF Cloud has worked with our nRF 91 series devices, which are cellular devices used in applications like asset tracking. But today, we have expanded nRF Clouds to include nRF 52, nRF 53, and nRF 54 series devices, and have built turnkey onboarding that makes connecting these devices and collecting data from them easier than ever. nRF Cloud under the hood is powered by Memfault, Nordic Semiconductor's latest acquisition, a proven category leader in the device infrastructure space. At its core, nRF Cloud provides three key product pillars. The first one is device management. Device management is how you keep your devices updated and secured. It includes provisioning, message passing, and over-the-air update functionality. The second pillar, and the one Memfault is most famous for, is what we call embedded observability. That is the ability to automatically collect data from your devices to identify and resolve problems fast. Our embedded observability offering lets you collect metrics, crash reports, logs, and other device health information directly from the field and look at it in dashboards, create alerts, and analyze the data yourself. Last but not least, nRF Cloud continues to offer location services. Those are API services that you can use to optimize location tracking for your devices. So you can get a location fix with or without GPS, faster, with less power and less device side resources needed. Today, we won't talk about location services in more details, and we'll focus on the first two. But if you're interested in those, please get in touch. We continue to build amazing things on the location services side as well. nRF Clouds is unique in that it is pre-integrated into Nordic devices and therefore very easy to use and cost-effective. You can integrate nRF Cloud with your projects in under 30 minutes of work. It is just a few config flag changes in your nRF Connect SDK. It is extremely cost-effective. You can start for free and scale for a few cents per device. We have built a number of plans, which I will detail later, which allow you to go from prototyping to very large-scale mass production at a click of a button and reasonable cost. Last but not least, it is tried and tested. Tens of millions of devices use nRF Cloud today. It is compliant, it can scale, and it works no matter what your device looks like. So how does it work under the hood? nRF Cloud comes with three components that facilitate the integrations of your devices with your cloud. First, the nRF Connect SDK bundles nRF Cloud functionality. A very, very small observability SDK is included, which requires fewer than 4 kilobytes of code space and 1.5 kilobytes of RAM. This is already in our nRF Connect SDK, and all you need to do is change a config flag to enable it. It is present across nRF 52, nRF 53, nRF 54, and nRF 91 series devices. Number two is the connectivity protocols that we have built support for. Whether your device is connected over Bluetooth, Thread, NB IoT, Wi-Fi, or other technologies such as Matter or NTN, you can route the observability and diagnostics packets over your connectivity link. You can leverage our existing mobile apps, such as the nRF Connect Device Manager app in the iOS and Android app stores, as well as our SDKs for those platforms to build your own applications. And you can use our secure connection to make sure that the data makes it to the cloud without anyone eavesdropping on it in transit. Last but not least, the third component is the cloud itself, which ingests all the data from the devices, reassembles the data, analyzes it, classifies it, and extracts signal from the noise. Because from hundreds of gigabytes of device data we receive every day, we find a few data points that actually are meaningful to engineers. And we use some amounts of traditional algorithmic methods and some AI to achieve that result. I'm going to dig into each of these features, starting with embedded observability. Embedded observability includes in-field device debugging, that is the ability to automatically collect crash reports and root cause them very quickly. It includes fleet health monitoring, which is the ability to identify and predict failures using metrics that are aggregated over the whole fleet and visualized in a dashboard. And last but not least, it includes product analytics, because sometimes you want to know more than just how is the device doing. You want to know what is it doing. For example, if you're building a camera, you might want to know how often the camera is used to record, which recording modes are being used. Is it doing slow motion capture? Is it doing photos? Is it capturing video? And at what frame rates? And you may also want to know what's the temperature during the recording. Putting diagnostics data in relation with the usage data gives you better ability to understand performance and to understand your devices than ever. Here's what it looks like. Here's an example of our in-field debugging feature. It automatically collects crash data when the devices encounter a problem. So for example, here we see a few screenshots of a crash. What do you see on that crash? You will see a backtrace. So how did your code get there? You will see registers and local variable. You will see some automated analysis. And most importantly, you will see correlation across your fleet. Which software versions see this crash? What other attributes from the device correlate with this problem? Fleet health monitoring is centered around dashboards, charting, and AI. So out of the box, we collect data around connectivity, battery and power management, as well as stability of the device. How often is it working as expected versus not? We then push all this data to the cloud where we let you inspect it at a device level. So here you can see on the right a chart of a specific device's connectivity statistics. But we also let you aggregate all that data and understand how it actually works across the whole fleet. What is the average number of disconnects that devices on version 1.1 see? Or what is the RSSI of your Bluetooth link, and has the average across your fleet or the median across your fleet changed from version to version? Is the 95th percentile of battery consumption grossly higher than the median, And are there devices that have a very bad user experience? This kind of analysis requires no data science, no SQL analysis, no code writing, just a few clicks in an intuitive UI that embedded software engineers can use extremely easily. We layer on top of it some AI features that will surface to you the most interesting insights and tell you in plain language how the AI believes your fleet is doing. Last but not least, on product analytics, we let you understand how your devices are used. For example, you may want to know for a fitness tracker, is my battery life different whether I'm using it on a run versus using it on a bike ride? Tracking, collecting features, connecting features to behavior and to performance lets you really get to the bottom of issues. It also lets you understand how are users engaging with the products. What are the pieces of the products that are most useful and seeing the most use? You may find, for example, that going back to my camera example, of the 50 recording modes that you've implemented in your camera, only 10 of them actually see use. This can help you make better decisions in the next generation of your products. At Nordic, we love to use our own tools to solve our problems at work. So when we built the Thingy 91X, we use nRF Cloud Observability to understand how well it was working and fix issues all the way up to launch and even afterwards. For example, we found a memory leak in an early pre-production version of the Thingy 90X firmware. And by collecting some data, which you can see on this chart, you see, the memory usage, the free memory rather, going down over time until the device resets. And pairing that with crash reports where we're able to collect a modem trace automatically when that crash was encountered, we're able to very quickly root cause the issue and ship a higher quality product that delighted users and saw fewer customer support requests. But of course, others use it too. Here's an example of a LTE connected wearable. A customer of ours from a few years ago who shipped a product with a GPS location built in. And what they had done is they had set a fixed time that they would turn the GPS on to acquire satellites and get a location fix. And in the lab, they had identified that most of the time they would get a fix within a minute 45. And so they could set a much higher threshold to establish some margin of safety and find that they would be confident that they would get a location fix every time. Using nRF Cloud Observability, they then collected how long it took to get the location fix, how many timeouts were seen, how many GPS requests happened. You can see some of this data in the charts that I'm showing. And they found out that they actually didn't need to keep the GPS running for nearly as long. So they were able to optimize the amount of time they turn on the GPS using real-world data, proving to themselves that over 99.9% of sessions would get a fix successfully, and improving battery life by 1 day, 20% as a result. So that's observability. Let's talk about device management. Device management makes maintaining your device much easier. We do this in 3 ways. First, we pair OTA updates with observability. So when you ship an update, you have total visibility on how it works, and you understand its performance so that you can pause the rollout or even revert it in the event that a problem occurs. Number 2, we have automated rollout management, which lets you create cohorts of devices that you want to update together and do a staged rollout that updates 5%, 10%, 30% of that cohort over time automatically so that you do not get all your devices on a new release and risk introducing a new problem. Last but not least, we have a one-click abort which lets you very, very quickly stop a release if there is a problem. That's not all. We have a number of very important compliance features, making sure that the updates are secured, that there's approvals, that the right set of people approve them, and that an audit log is maintained so you can always know who makes an update when. Here again, I want to show you a little bit of what it looks like. So here we can see a few screens that include the breakdown of versions out in our fleet. So you may see that the majority of your customers have not yet updated their device, and a small percentage are on the cutting edge. That gives you an idea of what can you expect in terms of support requests if you have an issue on your older version. We show you also how easy it is to set an activation threshold for your release. That is, specify what percentage of devices might get the updates. And we'll show you, we show you how you can very easily do this one button abort. We've got some great customers using nRF Cloud's OTA, including the team at Remarkable, which has been managing a very large fleet of devices using nRF Cloud for several years now, and have said some wonderful things about us. Getting started with nRF Cloud is very easy. As I mentioned, it's integrated in the nRF Connect SDK. So a simple 5-step process gets you streaming data in no time. Number one, you go to nrfcloud.com and you create an account. You've done this on 100 different services. It's just like any of them. Then on step 2, you select which product family you're using. If you're using the nRF 54, for example, you'll click on the button on the left. Number 3, you'll set up the SDK. That is, you need to download the SDK, get all the development tools on your machine, just like you would when you get your dev kit initially set up. Then you'll configure your project, build it, and flash it on your dev kit. And then finally, you will use the nRF Connect Device Manager app on your iPhone or Android phone to bridge the data from the dev kit to the cloud and download firmware updates back to the device. You can do this very quickly and see data flowing immediately. It is extremely satisfying to go from a dev kit you've just unboxed to streaming very sophisticated telemetry data like your Bluetooth connection parameters straight to the cloud in a dashboard. But better than tell you how awesome it is, why don't I show you? So let me go into a live demo and show you how it actually works. All right, so here is the nRF Cloud dashboard. And I know it looks like a lot, tons of menu items on the left, a lot of cars in the middle. I'm going to walk you through it and show you what you can do with all this information. So when you log into nRF Cloud, the first thing you'll see is the overview dashboard. A set of charts that we've configured and that you can change and update as you need to, so that you can see at a glance the information that is most pertinent to you. So here, for example, we're tracking how many active devices have come online in our fleet. We can see this is a new product that was released a little while ago. We see that every week we have a few more devices than the week before. So far, so good. We can see a distribution of software. So most devices are running our 1.0.0 release, and a few are running newer releases as we're testing new builds. And as we go down, we see more and more information about the actual performance. How many errors are being uploaded? What are the top problems in our fleet? And how many devices are impacted by them? How often are devices rebooting and what are the reasons for those reboots? So for example, on September 20th, we pushed a software update, saw a huge spike in reboots. That's no problem. We update devices, they reset. But on the day after, we see a big increase in how often the devices reboot, and we see a lot of these are asserts and users hard resetting the device by pressing the reset button or holding the power button. So that's indicative of a problem. And then at the bottom, we measure information that we think is important to keep an eye on, like what is our battery life and how does it change from one mode of work use to another. This is a fitness tracker, so you see that it's got 3.1 days of battery life in average use. But if you're in a high power workout tracking mode where the heart rate sensor might be on or the accelerometer might be using a faster data rate, we consume more power. All right, so we see already some information. Why don't we dig into this data to understand it better? For example, we see here assert at send thickness data to companion is one of our top issue impacting over 100 devices. Let's click on it and see what nRF Cloud can tell us about it. So here we get to see some detailed diagnostics information. What the issue is, and this title, by the way, is automatically generated by nRF Cloud, and how often it's occurred. Over 500 times this issue has occurred. Note here that nRF Cloud has automatically collected individual instances of this issue from a wide range of devices and aggregated it, so that instead of looking at 548 reports, you're looking at one report that aggregates all that data and has deduplicated it automatically for you. We can see the incidence over time, and we can see how it correlates to different attributes, like is this correlated with a specific production batch of our devices? Here we see it's pretty much evenly distributed across all, so in all likelihood it's not specific to a specific production batch. However, we see that it didn't impact our 1.00 release and only started happening with a 1.1 release. So we can tell that this is a new problem that we're going to need to get to the bottom of quickly. At the bottom, we have the information engineers need to fix the problem. We see the backtrace with all the different threads. We see registers and local variables. We see even globals and statics, and we can go and search for variables that we want to inspect, like the state of our UART driver. I know many of you like to use log to debug your issues, and of course we've collected logs here so that we can get to the bottom of this problem. At the top you can see a tab which says issue logs. Let's click on that. And here we can start looking at logs that happened contemporaneously to the issue. You see here some crash reports being collected. And this, by the way, is logs across different devices. You can see, from all those devices, the aggregated logs around the time an issue was seen on those devices. So this is why sometimes the timestamps will look a little wonky. So let's say we want to look at the debug level logs. Up. And we'll click search. It will filter those logs further. And we see here at the top, one of our logs says something very suspicious, which is a buffer whose address is 0, a null buffer. So we can go and we can search for all the logs across those devices that saw this problem. And in fact, we can do one better. We can click extend to all logs. So we can look at all the devices across our fleet, whether they recorded that crash or not, to see how often they've seen one of those null buffer logs. And we see that's quite a bit. And we can actually look at the distribution of this information. And you can see that we started seeing this log a lot more than before around early September, around the time we released these new updates. And we can see the distribution that this specific log is mostly seen on version 1.1.0, but not exclusively. So perhaps what we've done is we've made it worse with our latest release. Every piece of data in nRF Cloud is linked. So from the log, I can actually go inspect the device that has outputted that log. So here I'll go and click on the device ID for this device and go into what we call the device timeline. This collects and puts in one timeline all the data we collect from the device. You can see some reboots. You can see some what we call session data, which is in this case is different workouts being collected on this fitness tracker. And of course, you can see the metric data. There's a lot of it, so let's focus only on a few of them. For example, how much battery drop we see in a given amount of time, and whether the CPU is active or not. You can imagine how useful it is to correlate this data and understand what is actually driving battery consumption. We see that this device is running our offending software version 1.1.0. We can click on the version and get more information about it. And this is where Memfault AI comes in handy. Memfault AI is a feature built into nRF Cloud, which will tell you what we see from the data being collected in terms of trends, and what new issues might have popped up on this release. So here on 1.1.0, we can see that stability has decreased, battery life has decreased, connectivity success has decreased actually substantially from 97% to 77%, and connection uptime is slightly decreased too. So it seems like the bugs that we've introduced in this version have impacted all of our metrics. Thankfully, with nRF Cloud, we found the root cause, we've debugged the issue, and we've put together a new update that resolves the problem. So we can actually go and release it. This version 1.1.1 is our test candidate. Let's see if we can ship it to more of our devices. I'll click on 1.1.1, click Activate. I'll select my production cohorts, and I'll click on this Stage Rollout radio button. This will let me release to only a percentage of my fleet, let's say 40%, so that I can make sure that this does indeed resolve the problem, and I compare the behavior of this same cohort of devices with and without this update. I'll click to Activate, and nRF Cloud will start rolling out this release to all our devices. Last but not least, we'll use our dashboard to confirm that the issue has been resolved. So here we have what we call our device vitals, some of the key pieces of information we look at to know whether our devices are working well or not. And we'll compare our base version 1.0.0 against 1.1.0. And we see that indeed there's a big regression. Right? Our Bluetooth sync success rate, BLE sync success rate has gone down from 97 to 77%, just as the AI told us. And our stability has gone down from 100% to 95%. That doesn't sound like a lot, but a 95% stability rate means that 5% of the time the device is crashing. So in any 100 hour, it will crash 5 times. That's a lot. Let's now add our 1.1.1 release to this comparison and look at whether it's resolved the problem. And you know what? We've done a great job. The engineers had indeed found the issue. We regressed in 1.1.0, and we're back to the baseline with our newest release. So we've really been able to close the loop. We identified an issue at the top. Looking at our overview screen, we dug into the logs, we dug into the crash reports, we looked at individual device performance. We found the root cause, created a new release, and pushed it to our fleets, but only a percentage of the fleets so we could really compare the before and after. Last but not least, we confirmed using our dashboards that we had resolved the issue. All within nRF Cloud, all without writing a line of code, using battery life optimized, bandwidth respecting data tools. All right, that's it for our demo. So let's talk about what people have actually achieved with these tools. We've now been serving customers for years and have seen wonderful results. For example, one of our customers building a location tracker connected over cellular has seen a 19% reduction in support costs. Why does that happen, or how did that happen? Well, by quickly identifying the top problems, equipping their engineering teams with the data they need to root cause and fix them faster than ever, and then pushing updates to the fleets that resolve the problems, they were able to lower the number of customers who have issues and therefore reduce how many tickets get filed. That is a huge cost saving in terms of the lifetime of the program. Another customer building a short-range wireless connected consumer product was able to see a 40% reduction in firmware hotfixes. That means that their team was able to focus instead on building the next great feature in the next great software release, rather than rushing a hotfix to the fleets in order to resolve a burning issue. Another short-range consumer device saw a 3x increase in how many firmware releases they were able to get out in the year. So fewer hotfixes and higher confidence means you can actually ship faster and get great features and the best software you can build in your customers' hands faster than ever. This means that you can stay ahead of the competition and continuously delight your customers and reinforce their relationship with you. Last but not least, back to a long-range use case, one of those location tracking devices saw a 30% improvement in battery life. Battery life is one of the constant complaints in users of battery-connected device. So being able to just using observability data and software improvements drastically improve the battery life of a device is a huge win with no hardware changes needed. This all sounds great, you'll tell me, but what does it cost? So let's get into it. nRF Cloud offers 3 plans. And depending where you are in the size of your fleets and your product development process, you'll want one or the other. First is a developer plan. Great when you just have a few prototypes and you're trying to figure out whether this is the right infrastructure for you. It lets you use 10 devices for free and gives you access to all the features of the platform, including observability and device management. Once you're ready to get more than a few devices on the platform, you can move on to the Pro plan. The Pro plan is a pay-as-you-go offering that charges a fraction of a cent for every piece of data that you send to nRF Cloud. For example, every time you'll send us a crash report, we will increment your billing by a fraction of a cent. It is a great way to start using nRF Cloud when you don't have great visibility into how large your fleet will be. Last but not least, for larger customers who need fixed pricing, better support, onboarding services, and a custom contract, we have the enterprise plan, which is fixed fee, prepaid, enterprise-grade offering with a really strong customer support and professional services team behind it. Most customers will go through every stage of every plan as they develop their device, starting with a developer plan when they're prototyping, the Pro plan in development as they have a few more EVT type devices, and the enterprise plan ahead of production as they start forecasting growth. Most importantly, nRF Cloud is secure, compliant, and privacy conscious. Your data is hosted securely. We get audited every year, pen tested. It is encrypted in transit and at rest. You control what data is collected. So all data collected from nRF Cloud is opt-in, and you can make sure to exclude any sensitive data from the diagnostics collection. We let you delete data on demand, and we keep up to date with the latest regulations, constantly updating our platform, its security, and our internal processes. So you can trust that you're building on top of secure, compliant, and scalable infrastructure, no matter where you're at in your own product development cycles. I'll leave you on this amazing note from one of our customers. who said that their engineers would have a mutiny if nRF Cloud disappeared because it will feel like going back to the dark ages. Having been working on these tools for over 6 years, I can tell you that I also would feel like going back to the dark ages if I didn't have them. Because once you get used to working with data, understanding performance, and iterating based on real user experience, it's hard to imagine to going back to testing things in the lab, reproducing problems at your desk, and trying to intuit what may be happening out there. We hope you enjoyed this presentation. Thank you for listening. I know it was a lot of content, but as you can tell, I'm very excited about what we can do here with nRF Clouds. We have a long roadmap. We're continuing to build very exciting features. We look forward to sharing more with you and to having you along on this journey. Thank you. Okay, I'm ready for some questions. As you can tell, I changed shirts extremely quickly in between the presentation and the Q&A. Let's start with our first question. How do I integrate Memfault if my device only has Bluetooth Low Energy connectivity? Well, as you can imagine, it wouldn't be much of a launch supporting the nRF 54 and the 52 and 53 if we hadn't thought about the BLE connectivity use case. So here's how it works. First, we have implementing a new diagnostic service on the firmware side. We call it the Memfault diagnostic service, and it pushes the diagnostics data over BLE. On the other side, typically what you'll have is a mobile application. So we have built two things. First, a mobile app. You can go and check out the nRF Connect Device Manager app. It's in the Android App Store. It's in the iOS App Store. And you can also find the source on GitHub, so you can use it to build your own apps. And we've also built a library that is inside that app that you can reuse for your own projects. And what that library does is quite straightforward. It takes the data over BLE and pushes it to the cloud. Not all that hard to build yourself, but we figured it would be very helpful to have that yourself. And of course, on the cloud side, we receive the BLE chunks and we reassemble the data that we need to do our analysis. So this all works over BLE. If you want to learn more on how to get started on the nRF 54, nRF 53, and nRF 52, you can go on our Quick Start docs page for that series of devices, and I will drop a link in the chat in a minute. Next question. Is there an nRF or Zephyr sample that has Memfault observability features that we can build and flash for nRF 54 and nRF 51? So we don't yet have an example where nRF Cloud observability is enabled by default, but it's only a couple config changes. So if you go follow our quick start example or our quick start documentation, that takes only a few minutes to go through. You will see what we make you do is take one of the examples, change a couple of the configs. So you don't write more codes, you don't edit the code, you just change some of the configs to enable the SMP profile and enable the Memfault diagnostic service. And then you reflash your dev board with it. And then you're off to the races. So it's an example, it's just not precompiled. You have to change the config a little bit. Same thing for the nRF 91. And there's also a quick start page. In fact, let me drop the links for those right now. So here is the link for nRF 91 quick start. And here is the link for nRF 53, 54, and 52 quick starts. And while I'm at it, I'm going to give you the link for the nRF Connect Device Manager app, which has both the links to the app stores and the links to GitHub. So you can go and look at it. Let's go to the next question. Can nRF Cloud handle Delta OTA updates on Nordic devices or only full image swaps? So nRF Cloud does have support for Delta OTA updates. You can see, and if you look at our documentation and search for Delta updates, I'll also try to dig up a link for you. You'll see that we have built-in on the cloud side support for it. However, the current version of nRF Connect SDK does not have a built-in, Delta updates, image application algorithm in the bootloader in MCU boot. So you'd need to either roll up your own Delta OTA updates, or we are looking at some solutions on our sides. This is something I'm very interested in. I would like to provide an end-to-end solution for Delta updates, but the SDK side is still a little ways away. So long story short, the cloud can do Delta updates. If you know how to package your own Delta updates and apply them, you can use the cloud to manage them, and that's no small feat. But we'd love to have the complete end-to-end solution that includes the firmware too. So hang tight, we're working on it. Is there an option to manage a device which contains one or more nRF chips, as well as, for example, a single board computer? So yes, the really cool thing about the platform that we're building, combining nRF Cloud and Memfault, is that it works across a wide range of devices. So we support Linux devices, we support Android devices, we support, of course, MCU devices, whether they're bare metal, run Zephyr, run FreeRTOS, all kinds of configurations, actually. And we also support devices what we call multiple components. So that would be a device that has, let's say, an nRF54 as the radio, and perhaps a second MCU or a Linux SoC as well, running some of the workloads, because you have some complex workloads. And we'll let you model in our cloud application those two components, and you can have two different update payloads for each of them. So this is absolutely a configuration that we support, and in fact, we have a good number of customers that do exactly that. Next question. Are there plans to integrate with external cloud services such as AWS or Azure? Well, the answer to that question depends a little bit on the details. We already have CloudFormation templates and guides on how to integrate nRF Cloud and Memfault with AWS, for example. I think we may also have guides for Azure, but don't quote me on that. So what does that let you do? It lets you use something like IoT Connect to push data back and forth from your device to the cloud. So use that as your data link, as many of you do, I'm sure. And then set up a data connector to push data from the AWS side into nRF Cloud for the diagnostics information. So in other words, use AWS as the conduit for the diagnostics data and then push it into nRF Cloud. We already have customers in productions who do that. This is a very well-worn, a road well-traveled and a well-supported configuration. So if you want to hear more about this, just email us, support@memfault.com, or get in touch. You know, you can click the get in touch link on our website and we'll have someone talk to you. And you can look, I think if you Google or if you search AWS in our documentation, you'll see we have a cookbook for it. Pardon me. Next question. How does nRF Cloud handle collecting data if my device isn't always connected? Does it buffer metrics or crashes on devices? And how much storage does this use? Great question. So indeed, we buffer data on device. We let you specify where you want that data buffered. So in the nRF Connect SDK, you can set a configuration to say, I want to buffer data in RAM, for example. So you can set a little RAM buffer. As you know, if the device remains powered through a reboot, and if your bootloader doesn't erase the RAM, you can keep a little no init section of RAM, and it will persist through reboots. That may be a little technical from those of us, but this is something you can do. So some of our customers just use a RAM buffer to buffer the data, or you can buffer it on flash. And of course, when we're connected over BLE, that's the only way. You can't depend on connectivity. We have a customer, for example, who makes a door lock, and they're only connected when the user walks through the door, and a BLE connection can be established to the phone. Short period of time. So they upload whatever diagnostics data they can during that time, but the rest of the time the device is not connected. And of course it crashes and it does things. So you may still want to collect data then. So buffering it on device is the only option there. How much data do we need for that? That's actually up to you. So you tell our SDK, here's how much data I'm giving you for collecting diagnostics. And we will then do our best and optimize our own data collection to fit that buffer. So if you say, here's 100 kilobytes, great, we'll collect a bunch of data. If you say, here's a 2 kilobyte buffer, we'll also make it work. So this is all very configurable because we know devices have more or less space depending on the application. And how we manage that buffer, we basically turn that into a circular buffer. Next question. Can you talk about options for routing data from nRF Cloud to other services? Example, routing time series data to InfluxDB. So this is a little bit outside of my wheelhouse. So I'll talk high level, and I'm sure others can then, if you get in touch with us at support@memfault.com or nRF Cloud support, we can of course give you more information. But long story short, we provide something called the message routing service, which lets you push messages over HTTP or over CoAP. I think we don't talk enough about CoAP. I think CoAP is a very, very cool protocol. And I recommend if you're building a low power application that you look into CoAP, because by using CoAP, you send much less data over the wire, over the air. And so you spend less time sending the data, you use less bandwidth, and also you use less power. So let's say you push messages over CoAP, we can route them for you. How you do that, I don't yet know. I'm not as well acquainted with that part of our system, but it is something we do. So get in touch and we'll get you the right documentation. By the way, nRF Cloud is one of the rare solutions that supports CoAP. So if you're trying to build the lowest power, highest performing application, I'm a big believer in CoAP. We have a very experienced team building those CoAP endpoints, and I'd love to tell you more about it. Is white labeling available for any of the nRF Cloud services? What an interesting question. Get in touch. Email me, François.baldassari@nordicsemi.no. Let me just drop it in the chat because otherwise I know it's a mouthful. And we're always looking to do interesting things. If the use case is exciting, I'm sure we'll find a way to work with you on it. Can I customize what metrics are collected, or am I limited to the built-in ones shown in the demo? I should have said that earlier. Of course, you can use your own metrics. The demos are in effect a gateway to becoming more metrics aware. So you get some metrics out of the box. That's great because you don't have to spend too much time thinking about what might be interesting to collect. But what we want you to do is to use our SDK to add your own metrics. With 2 lines of code, you can specify a metric like the temperature of your device, which we don't collect out of the box, and push it into nRF Cloud. You don't have to figure out how you package that data over the wire. You don't have to figure out how to store it, index it, query it. We take care of all that for you. You just add 2 lines of code on your firmware, and boom, it shows up on the nRF Cloud side. So I'm putting a link right now in the chat that shows you how to use the metrics on MCU and how easy it is. And we hope you'll use that to great effects. Next question. Next question. Yes, there we go. Is it possible to integrate a front end to perform user login and data presentation? So I'm still not completely clear on what it is that you're trying to do. So perhaps email us, but what I'll say, if I understand the question properly, is we support everything that you can do with our front end via API. So if what you're trying to do is integrate our data or embed some of the information that we're able to surface into your own front end, that is completely supported. You can do it via our API. Get in touch. We can help you do that. And we understand why that might be valuable. You may want to bring other production data from your system into a single dashboard. Very interesting stuff. Next question. Can the application firmware on an nRF 9160 pass the data via an external non-Nordic COM module and have our server deliver the data to nRF Cloud? Yes, we are agnostic to the data path. So the way the nRF Cloud SDK works is that we break up the data into what we call chunks. The chunks are sized according to your configurations. You might say the chunks have to be 100 bytes, or you might say those chunks have to be up to 10 kilobytes. And we will size those chunks appropriately. It is then up to you to get that data to the cloud. If you're using the nRF Connect SDK and the nRF Connect Device Manager app, we have a data path for you. If you're on nRF 91, you are using HCP or CoAP directly. But of course, if you have a different data path, you can take those chunks and push them to the clouds. And we have an API to receive the chunks and process them. We don't care whether they pass through other comms modules or not. And in fact, we have customers today who do just that. We have customers who use Nordic radios, other radios, and third-party MCUs with Nordic radios, and so on and so forth. Any configuration you can think of. We have tens of millions of devices on the platform today. We've seen a lot of different types of devices. You can absolutely do this, and we're always happy to help. Next question. Suppose we have an nRF 52840 Bluetooth application. To use the cloud, I need to interface with a Wi-Fi bridge device in order to connect to the BLE service to cloud, right? The answer is yes, you have to have some path to the clouds. Typically, we find it's a mobile app, and we offer mobile apps for this, as I've mentioned before. But it also sometimes is gateways, and we can support different types of gateways. We're actually currently working on getting a Linux gateway solution that can forward our chunks received on the Linux gateway straight to the cloud. It's also very, very straightforward to write your own forwarder, because all it really needs to do is receive the chunks, turn around and post them. You don't need to reassemble, reorder, or do anything else with them. So it's quite easy to push data from your Bluetooth device to the cloud. And in fact, the largest group of devices on nRF Cloud and Memfault today is Bluetooth devices. Next question, perhaps our last question. Or was that our last question, folks? It looks like it was. Okay. Thank you, everybody. I think that's all the questions. And we're, in fact, a little bit over time. So I have to sadly say goodbye. We've put a number of links in the chats. But as always, you can find this information, or a lot of the information that I've shared, at docs.memfault.com and on the nRF Cloud documentation websites. Find us at memfault.com, find us at nrfcloud.com, and of course, never hesitate to contact us at support@memfault.com or on DevZone, where we're always happy to chat. I hope you all have an amazing rest of your day, and thank you again for your thoughtful question and participation in today's webinar. Have a great one.